How do I solve systems of equation using elimination? So if you have a system of equations like we do here, we have x minus y equals 11 and 2x plus y equals 19. We can actually add it or subtract the entire equations from each other to eliminate one of the variables, solve for the variable that is left over, substitute back in, and solve for the other variable, and get your ordered pair for the solution to the system. So in this system of equations, they're already set up nicely where I have the same coefficient on one of the variables in both equations. Since here it is minus y and plus y, the coefficient is 1. And it's set up really nicely because they're already opposite signs, so that means we would just add them together. That's the easiest way to solve these. And we simply say x plus 2x is 3x. Negative y plus y is 0y, which is 0. Kind of just cancels out. 11 plus 19 equals 30. I can divide both sides by 3. X equals 10. I can then substitute back into either of the original two equations to get the y value. I'll use the first one. 10 minus y equals 11. Subtract 10 from both sides. Negative y equals 1. Divide both sides by negative y. Y equals negative, or not, by negative 1. Divide both sides by negative 1. You end up with y equals 1. Our solution to this system is 10, negative 1. Sometimes you'll have problems that might be more so in context. How does this work in context? And in this situation, you have these two groups. The first group is they're ordering tacos, or T, and burritos, or B. And the first group orders 3 tacos, 3 burritos. It costs them $24. The second group orders 6 tacos and 5 burritos, and it's $42. What's the cost of a taco and a burrito, right? So we can solve for T and B to figure out the cost of a taco and the cost of a burrito just for one. And that's what we can figure out in this problem. Except in this case, none of the variables have the same coefficients to start with. We have 3, 3, 6, and 5. However, I noticed that there's a relationship between 3 and 6, and it's times 2. So we can multiply the entire top equation by a factor of 2, which will give us 6t, and therefore, we can then, at that point, we can then subtract. So 2 times 3t is 6t. 2 times 3b is 6b. 2, you have to do both sides of the equation in order for this to be equal. 2 times 24 is 48. So now, when I look at these two equations, and I see, all right, they have the same exact coefficient and they're the same sign, so I'm actually going to subtract them because 6t minus 6t equals 0. So this will be 0. 5b minus 6b is negative 1b equals 42 minus 48, which is negative 6. Then I just divide by negative 1. Negative 1 this is going to give me b equals 6. So I now know the cost of a burrito is $6. I can substitute back into one of the original equations to figure out the cost of a taco. I'm going to try and write small here, 3t plus 3 times 6 equals 24. 3 times 6 is 18. Then I have to subtract 18. 3t plus 18, 3 equals 24 minus 18. So then 24 minus 18 is going to equal 6. So I'll come over here. 3t equals 6. Divide by 3. T equals 2. B is equal to 6. T is equal to 2. What does that mean in terms of this equation? We don't need an ordered pair because we're not dealing with x and y coordinates. But this means that a burrito, it costs $6 and one taco costs $2 in this situation. There's a third type of equations that you'll need to solve with elimination, and in this one, you actually need to multiply both equations by a factor that will then create them into a common, that'll create equal coefficients on one of the two variables. In this case, I have 3x and 5x, so a common multiple of 3 and 5 is 15. And I could try and multiply both equations to get this to 15. I also have 2y and 5y. A common multiple of 5 and 2 is 10. So I could multiply to get these both to 10. And I'm going to choose the 10 because that's a lower number, so I'll be dealing with smaller numbers overall. You could also do the 15. It does not make a difference. So to get 2y to equal 10y, I multiply the entire equation by 5. And to get 5y to equal 10y, I multiply the entire equation by 2. So this top equation, 5 times 3x is 15x, minus 5 times 2y is 10y, equals 5 times 2 is 10. The second equation, 2 times 5x is 10x, 2 times 5y is 10y, equals 2 times 10 is 20. Now with these two, I have the same sign here. Both of them are minus 10y, which means I want to subtract them. So 15 minus 10 is going to be 5x. Negative 10y minus negative 10y is really plus, so then they cancel out under 0. 10 minus 20 is negative 10. 5x equals negative 10, divide by 5. X equals negative 2. Substitute the negative 2 back into one of the original equations. 3 times negative 2 minus 2y equals 2. 3 times negative 2 is 6, minus 2y equals 2. Subtract 6 from both sides. Minus 2y equals 2 minus 6 is negative 4. Divide by negative 2. Negative 4 divided by negative 2 is positive 2. Y equals positive 2. My coordinates would be negative 2, 2. That is my solution in terms of coordinates for this system of equations. And again, that is how do I solve systems of equations using elimination.